This is D. Suresh Krishna from Artificial Intelligence and Data Science Department in STEAM Manakal Engineering College. Let's get started. Hi guys, in this video we are going to see the logic gates implementation in Logical app. First you have to put the toggle key, that means input, and you have to implement the logic gates and one bulb. If you give the connections by through the inputs and give the connection to the output, this is called the AND gate, and many types in this gate: XOR gate, OR gate, NAND gate, XOR gate, and many gates. And this is the bulb, that means output, and this is the switch, that means input. Like this way, we are going to see the AND gate, OR gate, the variety of gate. In this AND gate, 1 1 is 1, and OR gate, the 1 1 is 1. In 1 0 also. In NOT gate, the 0 is 1, 1 is 0. XOR gate, the 1 1 is 0. In NAND gate, 1 1 is 0 and 1 0 is 1. 0 0 is also 1. 3 input NAND gate, 1 0 1 is 1. 1 1 1 is 0. 0 1 1 is 1. And 0 1 0 is 1. In XOR gate, 1 1 is 0. 0 1 is also 0. Now we are going to see the experiment number 2, adder. In this adder, the 0 1 is 1 and 0. 1 1 is 0 1. 1 0 is 0 1 also. 0 1 is 1 0, and this is the sum and this is the carry. In full adder we are going to give the inputs, and in subtractor also 1 1 is 0 and 1. 1 1 is 0 0. This is the boron, this is the difference. In full adder circuit we are give 0 1 0 and 0 1 1. 1 1 1 is 1 and 1, sum and carry. In full subtractor we are give 0 1 0, 0 1 1 and 1 1 1. The difference is also 1, the borrow is also 1. This is the adder, full adder, separator, full separator. This is experiment number 3, gray to binary and binary to gray. In this implementation we are going to give the input as 1 0 0 0, the output all are 1, and we give 1 0 1 0, the output is 1 and 1. 1 1 0 0, that means we are going to give 1 1 1 0 and the output is 1 0 1 1. We are giving 4 input at 1, the output is 1 0 1 0. This is binary to gray, and we are going to see the gray to binary. We are giving all the inputs are 1, the answer is 1 to 0 0 0, and we give 1 0 0 1, the output is 1 1 0 1, and we give 1 0 0 0, the output is 1 1 1. We are going to give 1 0 1 0, and this is experiment number 4, BC2 to XS3 and XS to BCD. We are going to give 1 0 0 1, the output is 1 1 0 0. In XS3 to BCD we are going to give the input as 1 0 0 1, means the answer is 0 1 1 0, and we are going to give 1 0 1 1, the answer is 1 0 0. And this is experiment number 4. Experiment number 5 is even parity and odd parity. We are going to generate the even and odd parity. We are giving the input as 0 1 1, the even parity is 0 and it is 1. We are going to give 1 1 1, the even parity is 1 and the odd parity is 0. Likewise we give the input as our conditions. And another experiment is experiment number 6, multiplexer and demultiplexer. This is the inputs S0 S1, D0 D1 D2 D3. If we give the S1 dash and S0 dash and give the D1, means the output is 0. If we give the S0 dash and we select the input as D2, the answer is 1. If we give the S1 dash and D1, means the answer is 1. Likewise we are going to implement the demultiplexer also. If we give the multiplexer D0 and 1, means the answer is 1. In demultiplexer we are going to give 3 inputs and get the 4 input outputs. If we give 1 1 1, the answer is 0 0 0 1. If we give the 1 0 1, means the answer all are 0. If we give 0 0 1, means the answer all are 0. This is the implementation. Now this is the decoder. We have to take 7 and 8 inputs and 4 OR gates to it, and we connect the Y1 and Y1 is simply we can leave. Y2 and Y3 we have to connect in the OR gate. Y2 and Y3 we have to connect, and Y4 and Y5 and Y6 and Y7, and connect the both OR gate to one OR gate to implement another gates, and also Y6 to Y7. Then you have to implement first and last gate to one OR gate, and the second to fourth one OR gate, and the third to fourth one OR gate, and connect it to one 3 bulb. First one is A, second one is B, and the third one is C. We have to give the input. If we give Y7 as input, the output is 111. If we give Y2, the output is 11, and so on you can give. And this decoder. Next we have to see the encoder. In encoder we have to give two input A and B, and one NOT gate to complement the inputs, and two outputs we have to produce two, so we have to give two AND gate. Now the output keys we have to give the bulb as well as. Now we have to first complement the A, and so you have to do 4 AND gate. You have to give A and B. Second you have to B and A dash, or A B dash. Next you have to give A dash and B, and you have to give both the input as A dash and B dash. Now you have to give the light bulb to produce an output and connect it to the bulb. If you give, now you can give the input as 0 1 1 0 and so on. If you give 1 0, the output is 0 0 1 0. If you give 2 input and last one is 0 0 0 1. Now we can see the flip-flops, and this is the clock symbol, and A and B two inputs. This is SR flip-flop, and this is D flip-flop, and this is JK flip-flop. You have to produce two output. One is Q and another one is Q dash. You can give three outputs A, B, and a clock, and connect it to Q and Q dash. If you give the input as 1 0, the answer is 1 and 0. If you give the input as 0 and 1, the answer is 0 1. Likewise you have to do for D flip-flop and JK flip-flop. And this is the various study of flip-flop, JK, SR and D.